All right, let's have a look at the questions we were working on yesterday, page 52. We already went over question number 1, so let's take a look at page 52, number 2 right now. We read through the question, talks about on-ramps designed so that motorists can move seamlessly onto highway traffic. Listen, lots of you have your driver's license already. Okay, lots of you are 16 and have your driver's license. If you don't have your driver's license, most of you probably have your learner's permit. You guys will know from maybe driver's ed if you've taken driver's ed. You'll know from certainly your driver's manual as you are studying it to take your learner's permit test. You know that the purpose of an on-ramp or an off-ramp is to get onto the highway or off of the highway at highway speed. Okay, it drives me crazy when I'm going down an on-ramp onto the highway. The speed limit on the highway is maybe 100 kilometers per hour, and you got somebody that's going 50 and kind of slowing down and looking over their shoulder because they're afraid to merge. The whole purpose of that lane is to get to highway speed, right? So that the slower you go on those things, the more likely it is to cause an accident, right? The closer you are to highway speed, the less likely it is to cause an accident. That's the purpose. So the question here is, if we need to increase the speed from 50 to 100 highway speed, and we can accelerate the car at 3.8 meters per second squared, how long does the ramp need to be? You're the engineer that's designing this highway. How long do you need to make the ramp in order that you can safely merge onto the highway at highway speed? Okay, a couple things here that I want to draw attention to in red. If you had this printed on your paper, this question, what would you circle in red? Kevin? Yeah, kilometers per hour, right? Just to draw attention to the fact that I want to convert those units. If I'm doing a velocity or a speed calculation, I could probably leave it in kilometers per hour if I wanted to. But if I'm doing an acceleration calculation, which I clearly am in this case, it's a group B problem, then I want to make sure I convert that to meters per second. All right, let's write down some givens here for question number 2 now. It says on-ramps are designed so the motorists can move seamlessly, blah, blah, blah. Increase the speed from 50 to 100 kilometers per hour. Something's going to be 50 kilometers per hour, and something's going to be 100 kilometers per hour. Tell me what the 50 is. Simon? Good. That's going to be VI, initial velocity, 50 kilometers per hour. Now, is that north, south, east, west? We don't really know, do we? Okay? It's the positive direction, okay? Whatever that is. What's the 100 kilometers per hour? Good, that's going to be the final velocity. We'll call it VF. We'll convert those. You know, do you want to convert them now or do you want to do it later? Do it now? Okay, maybe less chance of forgetting if we do it now. Okay, but in the end, we have circled those in red to help us remember if we choose to wait. Might not be a bad idea to do it now, though. I think 100 multiplied by 1,000 divided by 3,600 is 27.778 meters per second. And I think this one was 13.888. We're multiplying by 1,000 to convert kilometers to meters, and then we're dividing by 3,600 to convert hours to seconds. And this is what we get. We have an acceleration of 3.8 meters per second squared. Is that a positive or a negative acceleration? Positive. This car is speeding up, right? If this was an off-ramp where we were slowing down, then that would be a negative acceleration. They may not say it's negative. We may have to recognize it ourselves, but we'd certainly have to write it down as a negative. We want to find the minimum length of the on-ramp. We want to find the displacement. Now, understand what we're doing here, guys. This on-ramp can be longer than the displacement we calculated, but it must be at least this long. We calculate displacement based on these givens. We say, look, that's how far it takes the car to accelerate to 100 kilometers per hour. You want to make the on-ramp longer? That's fine, but make it at least this long. What equation from our list of group B equations do we want to use here? Jack? 2AD, good. That's the one I would use as well, right? We have VF, we have VI, we have A. We're solving for D here. Now, remember that VF doesn't stand for for final velocity. VF stands for final speed. But in the end here, we're not changing a direction. There's no issue with using interchanging velocity and speed here because we're not doing any kind of change in direction here, right? So don't worry about that. The fact that we put vector signs over it, it's not a big deal. Okay, solve for D here. What is the rule that we said yesterday that you got to do first? Get rid of what first, Max? Yeah, right. Get rid of what's not attached. Nick, can you tell me what's not attached to delta D there? Yeah, good. The VI. Right? How are we going to get rid of the VI if the VI is not attached to the D? Max? Yeah, let's try subtracting it. Now, if you have a little bit of trouble with that, you think maybe I added or divided or whatever, just try those and see if it works out. It won't unless you subtract it. VF squared minus VI squared equals VI squared plus 2AD minus VI squared. Okay. If you have trouble recognizing that these cancel out, put a number to it. Pretend VI squared is 10. 10 plus 2AD, subtract 10. It's just 2AD, right? The 10 and the 10 disappear. So the VI squared and the VI squared would disappear. That's why we know it's subtract. So we're left now with VF squared minus VI squared equals 2AD. And remember that we still have to solve for delta D here. So what is attached to this? Ashton, what is attached to the delta D here? Laura, what is attached to the delta D there? Good. And how do you get rid of the 2A? Right, it's multiplied by delta D, so let's divide it. It becomes VF squared minus VI squared divided by 2A. We divide it by 2A on the other side as well, but they cancel it out. I just kind of skipped showing that step. Is that okay? All right, so let's sub some numbers in here and see what we get here. VF was 27.778 minus 13.889 squared. Don't forget to square those. Last class, we were working on this question, and lots of people called me over. I bet 4 or 5 people called me over and said, I can't figure out what I'm doing wrong here. And I showed it. I said, you forgot to square. You forgot to square VI and VF. You just made it 27.7 and 13.8. You don't forget to square it. Acceleration is 3.8. Let's do this as a group on the calculator just to make sure that we can all do it. Say 27.778 squared minus 13.889 squared. Let's press enter. Some of you guys like to do everything all at once, and sometimes I do too, but I think especially if you're not an expert on your calculator, it's safer just to do top and the bottom separate. I just did the top, pressed enter. That's the top number there. Now, let's divide that by, put some brackets on the bottom, 2 times 3.8. And those brackets, oops, already did. There we go. See what I've done there? If I just said, look what I get when I do that, 76.146. If I had gone 578.712963 divided by 2 times 3.8, look what I get, 1,099. You got to have those brackets on the bottom in order to make that work, right? So my answer is 76 meters, and I assume that's the answer they gave me in the book. Sure enough, it is. Good. You like that question? I know you're thinking, well, I guess as much as I like any question, you're thinking. You're going to like this question. Except you're not going to like having to copy down the question. But copy it down, take a look at it. I'm going to give you a couple minutes to work on this yourself and see if you can develop a thought there. I probably won't give you time to actually solve the whole thing yourself. That's okay. I want to go through it with you, but I want to see if you can figure out at least a strategy for solving this. What's going on in this question? All right? Let's have a look. This question says a 1,600 kilogram car begins at rest at a stop sign and then accelerates at 4 meters per second squared for 5 seconds. Then it travels at a constant speed for 34 seconds. Then it slows down and stops in 8 seconds. How far does the car travel? Is this a group A problem or a group B problem? Constant velocity or acceleration? Group B? How many people say this is group B? Okay, how many people say this is group A? It's both. Yeah, that's the thing. Remember I said here when we introduced acceleration, like you really want to start thinking about what's going on before you start writing down givens. If you start writing down givens here without thinking about what's going on, then you're going to look for that tunnel vision, right? You're going to look for an equation that fits this entire problem, and you're not going to find it because there isn't a single equation that fits this entire problem. This is really three problems. Right? It's really three questions. Find the displacement in the first stage when it accelerates, then the displacement in the second stage when it goes at a constant velocity, then the displacement at the third stage when it slows down. We got to solve those really separately. And you got to catch that. You got to recognize it before you write down givens. All right, let's write down some givens, but let's do it for each separate problem. Problem number one. Problem number one, which is a group B problem because it involves acceleration. We're going to say that VI is 0 meters per second. It starts at rest. We're going to say that the acceleration is 4.0 meters per second squared. And we're going to say the time interval here is 5.0 seconds. Okay? Stage number one is done. We haven't solved it, but at least the givens for it are done. Problem number two, that's the second stage. How do you know we're doing something different here? What word in this question leads me to knowing that I've really got three different problems here? Then this happens, then this happens. It accelerates at 4, and then it travels at a constant speed for 34 seconds. We're going to make that a group A problem, right? Because it's constant speed. My time interval there is 34 seconds. And I think that's all I know about stage 2. Stage 3, there's a then again. This is a group B problem because it's slowing down, it's decelerating. We don't know much about this either. Time is 8 seconds. Anything else I know about stage 3? If I read between the lines, Keon? Good, VF is 0. Okay, it comes to a stop, right? Check. Yeah, the acceleration is negative. We don't know what the acceleration is though, right? Okay, so it's okay to write that down. I'm not sure that it's going to be overly helpful when we don't know what the number is though. All right, let's get the displacement in each stage and then let's just add them up to get the total displacement here. I think for this one, we're going to say VIT plus 1/2 AT squared. VI is 0. 0 times 5 is 0, plus 1/2 of 4 times 5.0 squared. 5 squared is 25 times 4 is 100 times 1/2 is 50, I think. Okay, good. There we go. Displacement in the first stage, 50 meters. Not my final answer, but I'm a third of the way there. All right, second stage, this is a group A problem where it's constant velocity. We know we're going to use the equation V equals delta D over delta T. It's the only one we can use for group A. We're going to rearrange it to solve for D. We get V times T. T is 34 seconds. What's V? Uh-oh. We need V. How fast is this car moving? We're not told. We're not told. Any ideas there? 20 meters per second? How do you figure that? Okay, so what you did is found the final velocity in the first phase. Okay, let's do that. Okay. A is equal to delta V over delta T. Delta V is equal to A times T. 4.0 meters per second squared times 5 seconds. That gives me a change in velocity of 20 meters per second. And since the initial is 0, then the final is 20. All right. If I'm speeding up 5, 10, 15, 20, and then I travel at a constant velocity, how fast am I moving when I'm moving at a constant velocity? 20. My constant speed for stage 2 is the final speed for stage 1. So let's write that down as another given down here now. We're going to say V, not VI, not VF, but V, because it's constant now, is 20 meters per second. I'm going to do it in a different color just to remind us that we didn't know what that was before until Jackson figured it out for us. But now I can find the displacement here. It's going to be 20 meters per second times 34 seconds. So I think when you do that, you get 680 meters. What about stage 3 now? What do you want to do there? It's group B problem, right? So it's not V equals D over T. Even though we have V, we're looking for D, we got T, we still can't use that because it's not a valid equation for group B. Yeah. Good, good. So we're recognizing that the final velocity from the first one is the constant in the second stage, and then the constant in the second stage is the initial for the third stage. Good. That's the reasoning that we want to get through here in our heads, right? Okay, it's not just as simple as writing down some givens that are in the question. We have to think about the question, especially a question like this, right? All right, so let's write that down as VI. Again, in red, just to remind us that we didn't know what that was before, but now we do. Okay, what do you want to do now? I'm thinking VI plus VF over 2 times T. I think that's going to work. I got 20 plus 0 over 2 times the time of 8 seconds. 10 times 8 is 80 meters. So what's my final answer to this question? How far has the car traveled? What is it? How'd you get that? Yeah, 50 plus 680 plus 80. What did it equal? 810? 810 meters. Should be technically be 8.1 times 10 to the 2 meters. Right? 2 significant figures. But Simon, you know that at this point I would mark that wrong, right? After your first unit test, I start counting sig figs. Is that okay? Listen, we're having a quiz on these equations tomorrow. You will not get a question like this on tomorrow's quiz. I'm not saying you'll never get a question like this, but it won't happen on tomorrow's quiz. Okay, tomorrow's quiz will be more straightforward, like, here's the situation. Okay, basically write down your givens, figure out which equation to use, and solve it. You might have a unit conversion there from kilometers per hour to meters per second, something like that, but no crazy rearranging and no crazy 3-stage problems. All right? Telling you though, the more of these questions you do and the harder of these questions you do, then the easier the basic questions that you're going to get on tomorrow's quiz seem, right? Have a look at page 52, questions 1 to 14.